children, today we are going to learn one of the most important lesson in your syllabus, electricity. Before starting the lesson today, let me tell you the learning outcomes of the lesson. Children, at the end of this lesson, you will be able to differentiate static electricity and current electricity, identify how electrons flow through a closed circuit, measure electric current and potential difference in circuits, find the relationship between the current flow through a conductor and the potential difference across it. These are the learning outcomes of the lesson today. Before starting our main topic, I want to remind you one of lesson you learned in grade 7, that is about static electricity. Can you remember, children, when you just rub your dry hair using a comb, or when you rub your dry hair using a ballpoint pen, small pieces of papers were attracted to the pen. Can you remember that situation? Yes, right? Why? Why these small pieces of papers are attracted to the pen? Because when the materials are rubbed each other, electrons are exchanged among them. Because of that, these objects or the materials are charged. These charges collected on these materials are called electrostatic charges. Right. Now look at here. When some materials like glass and silk, glass and nylon are rubbed each other, electrons move from one material to the other. Then one material gets charged positively and the other material is charged negatively. Right? Charges collected on surface of objects in this manner are called static electric charges or electrostatic charges. Right. Then what is static electricity? Static electricity is the electricity generated by friction when two substances are rubbed together. Right? Especially, this electricity does not flow through conductors from one place to another. So, this electricity must be used at the same place of its production. This is what the difference between current electricity and static electricity. Static electricity cannot be conducted through external conductors from one place to another, but current electricity can be transmitted from one place to another through conductors or through cables. Current electricity is the electricity that is generated in powerhouses like Victoria, Randenigala. There are hydropower stations in Sri Lanka. Right? When this electricity is produced there, that electricity is given to the national grid, and through the national grid we receive that electricity for our consumption. Today we are going to learn about current electricity. That is the kind of electricity that can be conducted through conductors. Children, what are conductors then? What are conductors? Right? Conductors are the materials that allow electricity to pass through them easily. Especially we know that metals are very good conductors because electricity passes through metals very well. Why metals are very good conductors, children? Because they have free electrons in them. how they can have free electrons in the free space of metals? You know, children, normally any matter is made of atoms, right? Now take a metal like copper. Copper also made of tiny copper atoms. These copper atoms, you know, normally atomic structure we have learned in grade 10 in the first term, right? We know that when the atomic structure is taken, there's a nucleus inside the atom at the center of the atom, and electrons are moving around the nucleus in different shells. In these metals, especially metals like copper, silver, gold, aluminium, some of electrons in their valence shell in the outermost energy level have moved to the free space of these materials. That's why metals have free electrons in them. Existence of free electrons in these metals help them to conduct electricity. Let us see, children, what will happen when this type of a conductor, metallic conductor, is connected to the two terminals of a power source like a dry cell. When a conductor is connected to the two terminals of a dry cell, electrons at the negative terminal starts to flow through the conductor towards the positive terminal of the cell, because there is high electron pressure at the negative terminal of the dry cell. Because of this high electron pressure, electrons release to the external conductor at a high pressure. This creates electron flow through the conductor from the negative terminal to the positive terminal. This results the flow of electric current from positive terminal to the negative terminal. Normally, electrons flow from the negative terminal to the positive terminal like this, and then it says the conventional current flows from the positive terminal to the negative terminal. Now you can see here electron flow towards this direction and the current flow towards the opposite direction. Now we are going to learn about some measurements of electricity. Children, you have learned about measurements of electricity in grade 8. What are the measurements of electricity? There are three main measurements. Number 1, current flow. Number 2, potential difference. And number 3, resistance. First, we are going to remind what we have learned about current flow in grade 8. We know that current flow is symbolized by capital I, and unit of measuring current flow is ampere. There are subunits of ampere called milliampere and microampere. Measuring instrument is ammeter or millimeter. The way of connecting this instrument to the circuit is series, and you can see the symbol, circuit symbol of ammeter. When an ammeter is connected to the circuit, the symbol must be given like this. Let me explain the way that ammeter is connected to a simple circuit with a bulb and the power source and a switch. Right. Here, children, I have an ammeter here and power source. There are two dry cells connected together and a bulb. This bulb is normally connected. This is not essential to connect to all the circuits, but just to identify where the current flows easily, a bulb can be connected. And this is the switch. You know the purpose of connecting a switch to the circuit, children. Why we are connecting a switch to the circuit? We can control the flow of current as we wish. If we want, we can switch off the current flow. We can stop the current flow, and when we want, we can switch on the circuit. Right. Okay. When the ammeter is connected to a circuit like this, you must consider several factors, children. First, the terminals must be carefully considered. You know, here you can see there's a red color terminal. This is called the positive terminal, and there are another 3 terminals. All these 3 terminals can be considered as negative terminals. Depending on the amount of current flows through the circuit, we can change the terminal of negative terminal as we wish. Right. And what I wanted to tell you, when the ammeter is connected to a circuit, the positive terminal of the power source must be connected to the positive terminal of the ammeter, and the negative terminal of the power source must be connected to the negative terminal of the ammeter. Right. Now, I am going to connect this ammeter to this circuit. Right. All are connected. Now, I am going to switch on the circuit. Here you can see when the switch is on, the bulb is lighted and the indicator of the ammeter deflects. By this, we can understand that there's current flows through the circuit, and by the reading of the ammeter, we can get the current flow. Children, I am going to show you the way that ammeter deflects again. When the switch is on, please observe the reading of the ammeter. Right. Now you can see the indicator of the ammeter deflects. Right. This is the way we measure electric current through a circuit. Now look at, children, when the ammeter is connected to the circuit, it is inserted inside the circuit in a manner like all the current flows through the ammeter. If any device is connected to a circuit that enabling complete current flows through that device, this method of connection is called series connection. Now, you should be able to understand this ammeter is connected to the circuit in series. Right. Then we will move to the next measurement of electricity, potential difference. Now, we are going to learn about potential difference. This is the circuit we arranged initially, right? Now, what is the potential difference? The electric pressure difference between the positive terminal and the negative terminal of a power source is called potential difference. There's another term called EMF or electromotive force. It is also measured by the unit volt. Potential difference also measured by the unit volt. But there is a little difference between potential difference and the electromotive force. Children, EMF or electromotive force is the force by which the negative terminal of the power source releases electrons to the external circuit. Both are a kind of voltage measured by the unit volt. Children, remember, most of the time when electric current is drawn from the power source, EMF decreases than the potential difference. Right. Now look at some basic things relevant to potential difference. Symbol V, capital V, unit of measuring potential difference, volt. Instrument, voltmeter. The way of connecting a voltmeter into the circuit is parallel. Now you can see the circuit symbol of voltmeter. When the voltmeter is connected to the circuit, we must show it like this. Children, now we are going to measure the potential difference across a device in a circuit. Right. This is a voltmeter. You can identify it by the letter V. When the letter V is printed, then you must know that this is a voltmeter. Similarly, like in the ammeter, there are terminals here too. This is the positive terminal. It is marked by red color, and these are negative terminals. According to the amount of potential difference in the circuit, the ammeter port can be selected. Right. Now, let me explain how this voltmeter should be connected to this circuit. Suppose we need to measure the potential difference across this bulb. Then the voltmeter must be connected parallelly with this bulb. This is how we connect parallelly, children. Right? Here also, you must remember this, children. The positive terminal of the voltmeter, I have used a red color conducting wire for this. This positive terminal of the voltmeter must be connected to the positive terminal of the power source, and the negative terminal must be connected to the negative terminal of the power source. Right. Now we have fixed all the devices correct, and now I am going to switch on the circuit. Right. Here, when the switch is on, the bulb is lighted and the indicator of the voltmeter deflects. By this, you can record the potential difference across the terminals of this bulb. Let me show you again, children. When we now switched off, then the indicator came to 0 in the ammeter as well. When the switch is on again, the voltmeter and the ammeter both shows certain values. This is how a voltmeter is connected to a circuit, children. Now you can understand, this is our main circuit. The ammeter is connected in between the main circuit, and this way is called series connection. And this voltmeter is connected externally to the main circuit. This method is called parallel connection. Children, don't you have any problem here? Why this ammeter is connected in series like this and why the voltmeter is connected in parallel? Let me explain the reason. Any electrical device like ammeter, voltmeter, bulb or any resistor, there is an internal resistance in any electrical device. When the internal resistance is more high, then it consumes more current. From the ammeter and the voltmeter, children, voltmeter has a great high internal resistance and the ammeter has a very low internal resistance. So, when the ammeter is connected in series inside the circuit, it doesn't matter because it doesn't consume much more current. The current we input, we give to the ammeter, flows out through the ammeter and gives to the whole circuit. But as the internal resistance of this voltmeter is so high, if this is connected in series, the total current of the power source is consumed by the voltmeter. That's why we connect this voltmeter externally, that means parallelly to the device of the circuit. Now we are going to move to the next part of the lesson. This is relationship between the current flow through a conductor and the potential difference across it. Children, to find the relationship between the current flow through a conductor and the potential difference across it, we have to do an experiment. This is really an experimental circuit setup. You can see here on the screen the circuit setup that we have to prepare. Right now, I am going to show you how this particular circuit is constructed really. Look at here, children. Now you can see here we have familiar devices, battery, voltmeter, ammeter, switch and the bulb. And I have taken another two new items. What is this, children? I think this is not new to you because you have learned about this device in grade 8. The name of this device is the rheostat. You can see an enlarged picture of the rheostat here. Let me explain this. Here it has three terminals, terminal A, terminal B and terminal C, and a large coil of nichrome wire. There are a number of wounds here, turns here, and a slide in contact. This can be moved along this bar to each direction towards this and that. By moving this slide in contact, we can control the resistance here. We can increase or decrease the resistance. Therefore, this is a variable resistor. This rheostat is a variable resistor. Why it is connected to this circuit is because we need to control current flow through this circuit in several instances. Right. Now, look at this, children. Here I have taken a coil. This white color coil is a nichrome coil. A voltmeter is connected parallelly to the nichrome coil in order to get the potential difference of the across the nichrome conductor. A battery, for this activity we need 6 volt potential difference, children. That's why I have taken 4 cells, 4 dry cells. Then this gives us 6 volt potential difference. And the rheostat also connected like this. Okay, children. Now I am going to switch on the circuit. Here you can see the brightness of the bulb has decreased than in previous circuits because there are so many devices connected to the circuit. As they have internal resistance, they consume a certain amount of current in this circuit. Right. Children, now you can see again when the switch is off, the indicators are returning back to their original position. The purpose of constructing, the purpose of arranging this circuit is to find the relationship between the current flow through this nichrome coil and the potential difference across it. For this particular activity, we need to record voltmeter readings and ammeter readings in 4 different instances. How do we change the voltmeter reading and the ammeter reading? By changing the resistance of this rheostat. When the resistance of the rheostat is changed, the current flow and the potential difference of the circuit too changes. Thereby, you can have different readings. First, I have moved this sliding contact to my left hand corner. Then this gives the minimum resistance to the circuit. Now, I have adjusted the rheostat to its minimum resistance. Right. Now, I am going to switch on again. Right. Now, observe what will happen if I move this sliding contact slowly. When I move this sliding contact slowly, here you can see the brightness of the bulb decreasing and the voltmeter reading and the ammeter reading too decreasing. Why this happen, children? Because I am increasing the resistance of this circuit. See, now this is what we have to do here, children. First, after adjusting to the minimum resistance, you have to switch on the circuit and record the voltmeter reading and the ammeter reading. Then, we must switch off the circuit immediately after taking the reading and keep few minutes for this nichrome coil to cool down. You know, children, when current flows through a material like nichrome, as it has a high resistivity, this coil gets heated. If it is heated, this relationship that we are going to prove cannot be proved accurately, children. We must keep the temperature of this coil constant throughout this experiment. To keep the temperature constant, we have to switch off the circuit and keep few minutes to cool down for this nichrome coil. Then after adjusting the rheostat to a certain level, again we can switch on the circuit and record the 2 readings of the voltmeter and ammeter. Again switch off and keep few minutes and adjust the rheostat again to a certain level and switch on the circuit and record the 2 readings. Similarly, we must continue to take 4 readings, 4 ammeter readings and 4 voltmeter readings. Right. Now, look at this circuit, children. This is the circuit diagram for the circuit that we made here. Right. Now, look at here. What can you see in this table? This table shows the data we collected from this activity. Suppose in the first instance we recorded the voltmeter reading as 1.5 V and current flow as 0.5 ampere. And in the second instance, we recorded the potential difference as 3 volt and current flow 1 ampere. And in the third case, 4.5 volt, 1.5 ampere. And in the fourth case, 6 volt and 2 amperes. Children, why do we collect data like this? To draw a graph based on potential difference and the current flow. Now look at, when those data collected are used to plot a graph like this, you get a straight line goes through the origin. Here we have taken current flow to the x-axis and the potential difference to the y-axis. When all the data we collected are used to plot this graph, we get a straight line like this. What gives by this graph, children? This graph gives an idea like this. When the current flow increases, proportionately potential difference too increases. This is what the relationship we wanted. Right, children? When the current flow increases, potential difference too increases proportionately. That means these two have a direct proportionation. Direct proportionation. That means potential difference V directly proportional to the current flow I. This is the relationship that we wanted to find. This relationship is given as a law. This law is called Ohm's law because this was found for the first time by the scientist George Simon Ohm. What this law states, children? This law states when the temperature of a conductor remains constant, the current passing through the conductor is directly proportional to the potential difference across it. Here it has a condition, children, when the temperature of a conductor remains constant. That's why during the activity I told you, we have to switch off the circuit after getting the reading. Just after getting the reading, we must switch off the circuit and keep few minutes to cool down the nichrome coil. Because if we continue to take readings, the nichrome coil gets heated and the temperature rises. Then it is a problem to prove this law. Right now you should be able to understand, children. This law is proved when the temperature of a conductor remains constant. When we go back to the table of data we obtained, children, here I can show you a thing like that. In the first case, in the first instance, if we divide potential difference by the current flow, see the potential difference 1.5 V and current flow is 0.5 ampere. When we divide 1.5 by 0.5, we get 3. In the second case too, when we divide the potential difference by the current flow, potential difference 3 volts and the current flow 1 ampere. When we divide 3 by 1, we get 3. And again in the third case, when the potential difference is divided by the current flow, we get 3. In all the cases, the answer is 3. Why this comes, children? George Simon Ohm found that this ratio between potential difference and the current flow, that means the ratio between V and I, is a constant always, and this constant value is equal to the resistance of the nichrome coil or the resistance of the conductor. That means V over I is a constant. This constant value is equal to the resistance of the conductor. By this, we can derive a formula, children. Look at here. Here, according to the Ohm's law, V directly proportional to I. That means potential difference is directly proportionate to current flow. And also we found V over I is a constant. What this constant? V over I is equals to R. That is the resistance. That means we can write V over I equals R. Finally, V equals IR. Right. This is the equation derived by the Ohm's law, children. V equals IR. Let me explain one example how to use this V equals IR formula to calculate any unknown measurement. By using this equation, children, if you know the current flow I and if you know the resistance of the conductor R, you can easily find the potential difference V. Right, children, suppose in a particular circuit, thus current flow I equals 0.5 amperes and resistance R equals 6 ohm. Then we can find potential difference V using this equation V equals IR. Here V equals IR. I is 0.5 ampere. R resistance is 6 ohm. Then when you multiply these two, 0.5 into 6, you get the answer 3. What we found here? Potential difference of this particular conductor. Then the unit of potential difference V. Then we can get potential difference when we know I and R. Similarly, when we know V and R, we can find I. And when we know I and V, we can find R. So, these are the equations that can be derived using V equals IR equation. If V equals IR, when we know I and R, we can get V. When we know V and R, we can get I. I equals V over R. When we know V and I, we can get R. R equals V over I. Right, children? Now we are moving to do some exercises, right? From this activity, I want you to do some exercise, right? Okay. Look at this question, children. The potential difference across a bulb is 9 volt and the current flow is 0.5 amperes. Find the resistance of the bulb. Here, children, I will do one for you, right? Here, first you must write the equation V equals IR. Now, what is the potential difference? It is given. V is given to you as 9V. And then current flow I also given to you as 0.5 amperes. Then what is the unknown thing? Unknown figure is R, resistance. Then we can find resistance. How to get the resistance? This is simple mathematics. You have to divide both sides by 0.5. Then you get R isolated. When you divide 9 by 0.5, you get 18 as the answer. Then this is resistance. What is the unit, children? This is ohm. Then the resistance of this bulb is 18 ohm. Right. Now look at the way that you get the answer. Okay, then move to the next question. The filament of a bulb has a resistance of 12 ohm. When it is connected to a power supply, a current of 0.6 amperes flows through it. What is the potential difference across the bulb? This is how you get the answer. Always remember, children, you must write the equation before simplifying, right? V equals IR. Then I is the current flow, 0.6 ampere, and 12 is the resistance here. And when you know the current flow and R resistance, you can easily find potential difference. Right. Then move to the next question. The resistance of a nichrome wire is 8 ohm. When it is connected to a power supply of 4V, what is the current flowing through it? Here too, we can use the same equation. See, V equals IR and resistance is 8 ohm and potential difference is 4V. What is the unknown factor? I. Then I can be isolated like this, 4 over 8, that is 1 over 2, half. Half equals 0.5 amperes. Okay, children. Then move to the next question. The graph given here represents the variation of potential difference with the current flow. What is the resistance here? Children, when a graph is given to you like this, and if you know the potential difference and the current flow, even this is a graph, children, you are given potential difference and the current flow. Then you can use the same equation to find resistance. To find the resistance, what you have to do? You have to divide potential difference by current flow. This is the answer. You get here V equals IR, R equals V over I. V is 5 volt and I is 0.5 amperes. Then 5 over 0.5 equals 10 ohm. It is the answer. Okay, children. Now move to the next question. Here it says, a group of grade 10 students arranged the following circuit in the school lab to prove a certain law. Answer the questions given below based on this activity. Now, you know, children, you are familiar with this circuit, right? This is the circuit that we made, right? Okay. Now, we'll see what are the questions asking based on this activity. Right. Now, before moving, just look at here, what are the devices connected, children? This is the switch, battery, ammeter, voltmeter and X. What is this X, children? This must be rheostat, right? And remember, when the voltmeter and ammeter are represented in this circuit, it is essential to mark the positive and negative terminals. See, this is the positive terminal of the battery. This is the positive terminal of the battery, and when the ammeter is connected, positive terminal must be connected to the positive terminal. And in the voltmeter too, the wire comes from the positive terminal must be connected to the positive terminal of the voltmeter. Right. Now, we will see the questions. First, which is the law that these students wanted to prove? What is the law, children? Ohm's law. Ohm's law, right? Next question. Write the above mentioned law. How to write the law, children? This law states that when the temperature of a conductor remains constant, the current flow through the conductor is directly proportional to the potential difference across it. This is how you must write the Ohm's law. Next question. Which is the instrument named as X here? I told you. What is that instrument, children? Rheostat. Rheostat. Next question. What is the purpose of connecting this instrument? To control the current flow through the circuit. Children, to control the current flow, right? Next, what are the readings needed to prove this law? And mention the instruments that each reading is taken. The two readings we got and recorded are potential difference and current flow. Potential difference is measured by the voltmeter and the current flow is measured by the ammeter. Next question. The teacher advised them to switch off the circuit immediately and keep few minutes off after taking the readings in a one time. Why? To keep or to maintain the temperature of the conductor constant. This is the reason. To maintain the temperature of the conductor constant. Draw the graph that they expected to draw by using the data. What is the graph? We learn, children. This is the graph, right? Here to the x-axis, I, current flow, to the y-axis, V, potential difference. When the data are plotted, we got a straight line goes through the origin like this. This is the graph, right? Okay. Then next question. What is the relationship between V and I according to the shape of the graph? What is the relationship, children? We got that the relationship V and I have a direct proportional relationship. This can be written as V proportional, directly proportional to I. This is the relationship we got by the graph, children. Next question. Write the equation you derived by the above mentioned relationship. What is the equation we derived finally? V equals IR. Okay, children. With that, we have come to the end of the lesson today. I hope you got a very good understanding of this special physics concepts in electricity. See you again with another lesson of the next part of this lesson, children. Goodbye, children.